Okay, now let's talk about variables. So an explanatory variable or the independent variable is what we think might affect a change in another variable. It might explain or cause the differences in the response or outcome or dependent variable. We can refer to that anyway, right? So for example, if we look at the number of hours you study, that might cause a change in your test performance, your grade on the test. So the explanatory variable there is the number of hours that you studied, and the response variable is the grade on the exam. Now, a confounding variable is one that affects the response variable and is related to the explanatory variable. And we can't separate the two from one another, right? We want to try and get rid of or control for confounding variables as much as possible. For example, let's say that we just said the amount of hours studying may affect your test grade. Well, so might when those hours take place, mightn't they? For example, if I'm studying at 3 in the morning the night before the exam, that's going to interrupt my sleep for the night, and I'm not going to get a good night's sleep and do well on the exam. So what I can do is measure not only how many hours I put studying, but try to control for when that studying takes place. That's eliminating that confounding variable of potential sleep deprivation. Now, a lurking variable is a potential confounding variable that is not measured or considered in the study, one that we cannot control for. For example, it is the case that when ice cream sales increase, the number of drowning deaths also increases. This is a known relationship. Does that mean that sales of ice cream causes drowning? No, there is a lurking variable there. The fact that more people buy ice cream in hotter weather and more people engage in swimming in hotter weather, right? So that's a simple example where you can't tease apart or remove that extra variable of the time of year. Okay, that would be a lurking variable. We do randomization with experiments to control for confounding variables as much as possible, the variables that we are able to control for in the experiment. So randomization is intended to make groups approximately equal in all respects except for the explanatory variable. So by doing this, any changes that we see in the response variable can be attributed to the association with the explanatory variable. So how can we do randomization? Well, we can randomize the type of treatment and randomly assign the treatments to the experimental units. So for example, if we are looking at a drug study where we're looking to see, let's say we have a new weight loss drug and we want to see, is this weight loss drug effective in helping people lose weight? Well, what I would do is I would have two treatments, one treatment where they receive the active weight loss drug and one treatment where they receive a placebo, a sugar pill that doesn't actually affect their weight loss. And so both individuals in the two treatments would believe they are taking some sort of pill which may or may not affect their weight loss. So they're in exactly the same type of conditions, right? And then I would randomize people's assignment to one of those two treatments. That way I'm making sure that I don't have all the morbidly obese patients in one condition and all of the minor, moderately obese patients in another, right? Because the degree of weight loss we have to do might affect the amount that somebody actually loses during the study. The other thing we can do is randomize the order of treatment. For example, if I'm asking people to both, drive so I can see what their baseline performance is and drive while texting, right? I can randomize the order in which I do that, have some participants drive just no texting first, and then have other participants drive with the texting first. That way I am not seeing an effect